Why will we be doing so many of these? The answer is because you can do so much with them. That we can do so much that we would like to do to demonstrate things about the logic, demonstrate its features, and demonstrate what the logics themselves can do. So, here's something I have here. With once again, I don't know what inspired me to write the D that way, but demonstrate that modus ponens is valid. I'm going to skip over a little complexity with the word valid here and this symbol. But this is in the conventions we will be using in this class. The statement that modus ponens is valid for the formal logic named PL, propositional logic. So it means if you take the formulae on the left, comma is not a system, it's not a symbol in the system in the logic, it just is a separator, meaning these are two different formulae. If you take both of these formulae and you assume them, then you can derive Q. Take if P then Q, and P, and you can derive Q. This isn't going to look like much in the system of truth tabling that we have, because it's very basic. And indeed, when it comes to very basic things, they're just going to be reflected in a very basic way in the tableau, in the means of representation that we have. So how would I set this up? Well, for any truth table, to demonstrate that an argument form is valid, you assume that the premise formulae are true, and then you, using the rules of the system that preserve truth, get to the conclusion, which is Q. And so in a truth tree, what do? Well, you take the premises as true in the argument. So we start up here. This is going to be line 1. If P, then Q. Line 2, you don't have to number them. P. It can be helpful in long truth trees, but starting out very basic here, we don't have to number them. And so we put these at the top of our tree, meaning these are taken to be true. Further possibilities might, if we wanted, branch off. But we put these at the top, and that means that regardless of whichever possibilities would later branch off from up here, under all of them, these would be true. These formulae would be true. So this forms the core. If you want to, you could put a line there, because, okay, those are the starting assumptions. If this were a game, that would be the starting board here for this particular problem, where the pieces are arrayed. You start with these two things. From these, we demonstrate Q. Now, I'm going to tell you, it's a basic rule in our system that this conditional, well, when the antecedent is true, the consequent follows, and you can get the consequent out of it. The antecedent is P, the consequent is Q, so we know that if P is true, then Q is true, and we're also just given P, so guess what? You can immediately get Q. So on all possibilities, and there's only really one, where both of these are true, Q follows, and is also true. And then, because you've achieved your goal, you put a check. There is basically the most basic truth tree I can give you. We'll start getting a little more complex in the next clips.